All right, welcome to our class on hardware classes. So what is a hardware class? It's a class to manage everything. Usually you'll have all of your initializations, all of your code is going to be in every teleop and auto mode, right? So all of our DC motor initializations are going to be duplicated and control C'd across every single op mode. So what's a way to fix that? We can use hardware classes. They're easy to use and easy to sync across, and make sure you don't get code discrepancies in multiple teleop modes. So this right here is an example of what a well-defined one may look like in teleop. As you can see, there's not that many lines. Like realistically, there's 1, 2, 3, 4, 5 lines total. And that's all your teleop will need inside the class. So for a direct comparison, before you would initialize every motor separately in each op mode. But now with hardware classes, we can initialize every device one time in the hardware config class whenever we tell it to. So what are the steps to do this? We create a hardware config Java class. We create the variables for op mode, which you can name op mode with lowercase or whatever else you need. Plug all the variables as you would do in a teleop into the same area as normal. And then create functions. Really, init and do bulk are the ones that I really like to do. Telemetry is also really nice, but it's your preference. You can also rename these. I would just make sure init is always named init because it needs to be very, very defined what init does. So first of all, do all your robots set up in the initialization method. Do all like your normal loop things that you would do in while op mode is active in do bulk, and then telemetry. You can just add that all in bulk telemetry. And the reason we do this is to segment things off and make it easier to understand. So for our initial setup, we'll have our public class hardware config, and we will define a variable op mode, which will get passed in as a parameter into our constructor, which then we'll pass back through our constructor back into our variable. So now we have an op mode we can use inside of our hardware class. So now we'll add our typical devices where we're just going to add our DC motors and our IMU. So we can define a hardware map, HW map is equal to our op mode.hardware map, just so we don't have to type this out every single time. Because our op mode, which we've defined way up here as off mode, linear op mode, right? Then we can use the hardware map defined in our op mode to get each one of these devices, plus our IMU. And then we can call op mode.telemetry.update, which will take the telemetry from the op mode and update it. So next, what we're going to do is we'll add a telemetry. So we'll just make this new variable, telemetry, my telemetry, and we'll just add it to the constructor just to make it easier. But this .opmode.telemetry refers to this op mode, and then that's telemetry. And then we'll call it this.myTelemetry, which is the name right here. And we'll add the data for IMU velocity, and we'll just do all that. And then at the very bottom, very, very, very bottom, right before the semicolon, or right before the bracket, we'll update it. So next we have do bulk. This is the one where you're going to put all of the code that normally would go inside your teleop for your while op mode is running or while op mode is active. Essentially, for this one, we're just going to take our op mode, right, as we've defined before, .gamepad, and that will give us our gamepad 1. And then we're just going to do normal. We're assuming this is a Mechanim drive robot. We're just going to do that. So if you wanted to add another motor, you could do that. You just have to redo all the steps again and go back through and make sure everything's added in the correct spaces. And then at the very end, again, the end, we do bulk telemetry. And this is going to call that method that we defined last slide and show us our telemetry. You may also notice that our powers are down lower. Ideally, those are at the end with bulk telemetry, just because sometimes it's easy to set power in multiple places, and we want to make sure that doesn't happen. So if we want to incorporate this with subsystems, it's extremely easy. My robot is built off this software design, mainly, for the past couple years, and the methods coincide and are very easy to call. So let's go through an example. So we'll add our arm subsystem and drive subsystem variables, and then that's it for the first part. We just add those. Then we plug them into our init method, where we'll take arm subsystem, which we defined the last one, equals new, and then the class with our hardware map as our input. And then the same thing for drive subsystem, where we'll do the new drive subsystem and pass in this .op mode. This is going to largely depend on how you have your subsystems defined, but the main thing you need to make sure to do is initialize it. So if your constructor, if constructor in subsystem calls init, don't call it here. So do not call init twice. Otherwise, call it right here as you normally would. That should be a pretty self-explanatory reason why. We just don't want to initialize things multiple times. But just make sure you're calling things when you're supposed to be calling them. That's one of the most difficult things to figure out and one of the most difficult things to debug. So for the next part, we have these nice two methods for our ARM subsystem and drive subsystem where we will update them. That's all we need to do. We just tell it to update. And every loop, it will go through the update method that we've defined inside of our ARM subsystem and drive subsystem, and it will update them. That's all we need to do there. For bulk telemetry, we have this nice telemetry method in our ARM subsystem and drive subsystem, and we pass in our new telemetry methods right here and here. That's all we need to do. Now we have our subsystems telemetry from both of them. So if we want to use this in a teleop, we need to make sure we define our variable up here. So this one's a variable. Then we make sure it's actually defined. And you can see, as for our op mode parameter, we're passing in this, where this is referring to our demo teleop class. So this is going to be able to use the hardware map, the gamepad, the telemetry. It'll be able to use everything. And then all we need to do is we call robot.init robot. And then our initialization steps are done. It will do everything by itself that we've defined. Super easy. Then we call our wait for start, and while op mode is active, we're just going to do that do bulk method, which is where we've placed all of our other code. So the reason this is so easy is because now what you could do is you could say, if we want something in blue, but not in red, right? We can pass the color as a parameter into our hardware config. And then we configure it using if statements to tell us what will happen with if it's selected as a red teleop or as a blue teleop. And it makes our code way more concise very quickly. So to use an auto, it's not nearly as straightforward, but you will have access to all the same devices. You can initialize the robot and then use robot dot to access things. So like we could do robot dot drive subsystem, right? Dot drive forward. Let's just say that method exists. Drive forward. We'll say that method exists. But you could do something like that. Typically, it's easier to also have an auto hardware which will extend hardware config. So like class auto extends and this will help because it will allow you to use everything that's already defined in hardware config. So you can initialize everything, you can access all the variables, all that good stuff. So as for a conclusion, it takes a little bit longer to set up, but overall it'll save you a lot of time for debugging. It makes it have a singular place to debug. And as I said before, parameters can change how your robot initializes if you want different initialization steps or even just different operations to happen for like the do bulk function if you're on red or blue lines. And everything in this class can be completely dynamic based on what you need it to do. And you can customize this quite a bit. I find it's a little bit of a learning curve to get it set up, but once you have it set up, you can just keep reusing it. And it doesn't take that much modifications. So, thank you for watching.